Assalamu alaikum, dear students. Today we will discuss the PAM's work energy theorem, or this is also called the work energy principle. Frequently asked in the examination, work energy theorem or work energy principle. Work energy theorem or work energy principle is defined as the work done by a body, or first of all we will try to write a work energy theorem is defined as work done by a body or on a body is equal to change in kinetic energy. This is the definition. That means work energy theorem is defined as the work done by a body or on a body is equal to change in kinetic energy. This is called work energy theorem. Again, we know that kinetic energy in previous class, it is the energy possessed by a body due to the state of motion. Ultimately, we have got kinetic energy is equal to 1/2 of mv square, where m is the mass of the body and v is the velocity of the body. We have discussed it in the previous class. Again, we suppose here, suppose this is the body of mass m. Here, its initial velocity is u. It is the initial when we apply force F on the body. Suppose its velocity increase here. When we apply force in the same direction, its velocity will increase. Suppose after some time t, it covers a distance s, and its final velocity becomes v. Its velocity can also be decreased. That is another case here. But we suppose here its velocity increases from initial velocity u and its final velocity becomes v. And when its velocity changes from u to v, it produces it when velocity changes from u to v on applying force F, it suppose produces acceleration A and covers a distance S. I hope you have got it. That means body is initially having a velocity u. We are applying a force along the direction of along the same direction, and its velocity gets changed from u to v, and it covers a distance at. When this velocity changes from u to, it produces an acceleration b. The acceleration produces is a. Again, we know that force किसके बराबर है? Force is equal to mass into acceleration. ये आपने already पढ़ा है mass. We know that work done is equal to is equal to force into distance. Work done is equal to force into distance. That means F into S. Force किसके बराबर है? Mass into acceleration. Force that means ma into S. From third kinematic equation of motion, we know that 2as is equal to v square minus u square. We are already done. That means acceleration is equal to v square minus u square divided by 2s. When we substitute the value of acceleration in this equation, we get here mass into acceleration. Instead of acceleration, we write v square minus u square divided by 2s multiplied by s. Okay, this is 1/2 of m v square minus u square. 1/2 of m v square minus 1/2 of m u square. But 1/2 of m v square is the final kinetic energy. If you see here, it is the final kinetic energy. 1/2 of m u square is equal to initial kinetic energy, where 1/2 of m v square is equal to final kinetic energy. 1/2 of m u square is equal to initial kinetic energy. That means final kinetic energy minus initial kinetic is equal to change in kinetic energy. But here velocity increases from u to v. U to v, we can say this change in kinetic energy is the increase in kinetic energy of the body. Similarly, when velocity कम हो जाएगी, then there is a decrease in the kinetic energy. Okay, therefore work done by a body is equal to therefore change in kinetic energy, or we can say increase in kinetic energy. That means work done. Therefore work done is equal to work done by body is equal to here we say increase in kinetic energy. Increase in kinetic energy is changing increase in kinetic energy of the body. Similarly, if it is velocity decreases, similarly we can show that if some work is done, if velocity decreases from the body, kinetic energy of the body decreases by the same amount. Similarly, we can say we can show that if some work is drawn from the body, kinetic energy of the body decreases by the same amount. If work is drawn from amount, this proves work energy theorem or work energy principle. That means total work done is to change in the kinetic energy. This proves work energy theorem. It's simple, eh? That means simply I can make work energy theorem or work energy principle. This is the famous principle or famous theorem. Work energy theorem is defined as the work done by a body or on a body is equal to change in kinetic energy. We know that kinetic energy is 1/2 of mv square. Suppose body has initial velocity u, and when applying a force F, it covers distance s during a time t, and its final velocity becomes v, and there is a change in velocity. When there is a change, it produces an acceleration a. We know that force is equal to mass into acceleration. Work done is equal to force into distance. Instead of force, I can write ma. But we know that from third equation of kinematics, v square minus v square is equal to 2as. Ultimately, we get a is equal to v square minus v square divided by 2a. We can substitute here. Ultimately, we get 1/2 of m v square minus u square, or m 1/2 of m v square is equal to final kinetic energy. It is the initial kinetic energy. That means final means that's the change in kinetic energy. That here it is this change is in the form of increase in kinetic energy. Similarly, if it is velocity decrease, we can show that some work is drawn from the body of kinetic energy. Kinetic energy of the body decreases the same amount. That when it decreases with the same amount, when we increase or decrease, that means when work is drawn from the body, it decreases the same amount of kinetic energy. This proves work energy theorem. That means work energy theorem is equal to change in kinetic energy of a body. I hope you have. Thank you very much.